A standard deck of cards has 4 suits: hearts, diamonds, clubs, and spades, with 13 cards each for a total of 52 cards. We're going to find, or we're given some probabilities for drawing 2 cards from a shuffled deck. The probability that the first card is a heart is 1 out of 4. The probability that both cards drawn are hearts is 1 out of 17. And the probability that the second card is a heart, given that the first card was a heart, is 4 out of 17. You choose 2 cards at the same time from the shuffle deck of cards. Let event A be that the first card is a heart, and let B be that the second card is a heart. We want to know, are events A and B mutually exclusive, independent, neither, or both? So let's translate what we've been given here. We're told that the probability that first card is a heart is A, and that's going to be 1/4. Probability that both cards drawn are hearts is 1/17. So the probability that both A and B happen is going to be 1 out of 17. And we also know that the probability that the second card is a heart, given that the first card was heart, so B given A, is 4 out of 17. So here's the thing. If we were drawing from a second deck instead of the same deck, the second card's probability to be a heart would still be 1/4. But we see here that this conditional probability isn't 1/4. So what if we had probability of B given that it wasn't A, right? So think about it like this. Probability of B given not A. We could also think about it where if I didn't draw a heart the first time, there are still 13 hearts left in the deck. And I drew 1 card out, so there are 51 total cards in the deck. So the probability of B is not the same if I drew a heart versus not a heart on the first card. So this means that events A and B are not mutually exclusive because they can both happen, right? But they're not independent either because what you draw for the first card affects how likely it is to get hearts on the second card. So this is neither in this instance.